ब्लॉक 1 कंप्लीट कर चुके हैं पढ़कर, अब कंप्लीट करेंगे ब्लॉक 2। तो ब्लॉक 2 में पहला यूनिट है मेमोरी मैनेजमेंट। मेमोरी मैनेजमेंट का सिंपल वर्जन में हम पढ़ेंगे। तो पहले एक बार पीडीएफ में देख लेते हैं पीडीएफ में किस तरह से है। मेमोरी मैनेजमेंट के अंदर इंट्रोडक्शन तो आएगा, ऑब्जेक्टिव भी आएगा, ओवरलेज एंड स्वैपिंग, लॉजिकल एंड फिजिकल एड्रेस स्पेस, सिंगल प्रोसेस मॉनिटर, कंटीजियस एलोकेशन मेथड, पैजिंग, सेगमेंटेशन, ये सारा उसके बाद यूनिट 2 में वर्चुअल मेमोरी। तो पहले इसको कंप्लीट कर लेते हैं। यूनिट 1 memory management introduction. In a block 1 we learned the basic of operating system, process management and deadlock. In this unit we will learn about another important function of the OS, memory management. Memory is a key part of how a computer works. It is a big group of storage location, words or bytes, each with a unique address. The CPU interacts with memory by reading from and writing to these addresses. When a program runs, it is the first from the hard disk and put into memory. To run the program must be placed at a fixed address in memory. In multiprogramming, to use the CPU better and make the system faster, many programs are kept in a memory at the same time. There are many ways to manage memory depending on the system. The choice depends a lot on the hardware. Each method needs a special hardware support. The operating system does these tasks for memory management. Tracks which memory part are used and who is using them. Choose between processes to load when there is a free memory. Give and takes back memory as needed. As multiprogramming, the OS gives memory to many processes at the same time, so memory affects system performance. Software support, reliability and stability. Memory is of two types, primary memory and secondary memory, like cache and RAM, secondary like hard disk or magnetic tapes. Memory management be managed well. The OS part that handles this is called the memory manager. The OS part that handles this is called a memory management. In multiprogramming, memory is shared by many processes. So the speed of memory use and smart use of memory is very important. Protection is hard because the program's location is क्या है? Protection is hard because the program's location in memory is not fixed. But at runtime, hardware can help by stopping process from accessing other process memory. This unit explains these memory management duties of OS. There are two main types of memory allocation. Contiguous memory allocation, non-contiguous memory allocation. The whole program is stored in a contiguous block memory. Okay. So there is two main types of memory allocation, contiguous memory allocation and non-contiguous memory allocation. The whole program is stored in one contiguous memory block of memory. Example, program A uses memory from addresses this to this. A non-contiguous memory location, the program is stored in separate part of the memory, not together. Okay. तो कंटीजियस में क्या है? द होल प्रोग्राम इज स्टोर इन द कंटिन्यूस ब्लॉक ऑफ मेमोरी. नॉन कंटीजियस है द प्रोग्राम इज स्टोर इन सेपरेट पार्ट ऑफ द मेमोरी. दिस यूनिट फोकसेस ऑन कंटीजियस मेमोरी एलोकेशन, ओवरलेज एंड स्वैपिंग, बाइंडिंग, assigning memory addresses, compile time, load time, execution time, dynamic loading. तो बाइंडिंग में ओवरलेज एंड अच्छा ये तो इंट्रोडक्शन पर है. ओवरलेज एंड स्वैपिंग ये है. कंपाइल टाइम, लोड टाइम, एग्जीक्यूशन टाइम, ये ओके, ओवरलेस एंड स्वैपिंग. सो क्या बोल रहा है? ओवरलेस एंड स्वैपिंग बाइंडिंग assigning memory addresses, compile time, load time, execution time, dynamic loading. Only the main program is loaded first, other part are loaded when needed. Some memory programmers handle this. Overlays used when program is bigger than memory. Program is split into parts, load only one part at a time into same space. Other part are removed when not needed. Memory 140K program parts read function. Okay, swapping load full process into memory, send back, roll out. Rolling benefits can more program can run, better memory use, help with priority scheduling. Limitation, whole process must be memory, needs exact memory info, slow if used too often. Example, time calculation. To swap दिस इज बिट कंफ्यूजिंग टू अंडरस्टैंड. एक बार मैं यहाँ से पढ़ती हूँ. ओवरलेस एंड स्वैपिंग यूजुअली प्रोग्राम अकॉर्डिंग टू पीडीएफ में कैसा लिखा हुआ है. Usually programs reside on a disk in the form of executable files. For their execution they must be brought into memory and must be placed within a process. Such program from the ready queue in general. इसको थोड़ा समराइज करके पढ़ना पड़ेगा. चल मैं आगे बढ़ती हूँ. इसको बाद में पर और अच्छे से देखेंगे. अभी के लिए आगे बढ़ती हूँ, नहीं तो मैं वहीं फंसी रह जाऊँगी. लॉजिकल एंड फिजिकल एड्रेसेस स्पेसेस. Logical and physical address spaces. A computer uses two kinds of addresses to find data in memory. A computer uses two kinds of addresses to find data in memory. First is logical addresses and second is physical addresses. Logical addresses also called virtual addresses. Logical is also called virtual addresses made by CPU, used by programs when the program's things is the address. Okay. Physical address used by the hardware, actual copy, the real place where data is stored. Physical addresses. So a computer uses two kind of addresses to find data. लॉजिकल एंड ये एड्रेसेस है तो फाइंड द डेटा. डेटा तो समझ में आ रहा है. डेटा टू फाइंड, किसी का भी फाइंड करने के लिए उसका आइडेंटिटी प्लेस होता है. दैट्स वे इसको हम इस तरह से समझ सकते हैं. कंप्यूटर यूजेस टू काइंड ऑफ एड्रेसेस टू फाइंड डाटा. तो डेटा का एड्रेसेस, लॉजिकल एड्रेसेस, फिजिकल एड्रेसेस कॉल्ड बाय वर्चुअल एड्रेसेस मेड बाय सीपीयू, यूज बाय प्रोग्रामर. और फिजिकल एड्रेसेस में यूज्ड बाय हार्डवेयर द रियल प्लेस वेयर द डाटा स्टोर. हाउ दे वर्क टुगेदर. The operating system changes the logical addresses into physical addresses. Okay, the OS changes the logical addresses into physical addresses. This change is done using a special hardware device called the MMU, Memory Management Unit. Real life example to remember. Imagine if you order a pizza to your nickname addresses. You give the delivery boy blue house near the park. This is the logical address. But the delivery company has a map with real street name and house number. They change your blue house near park. This is the physical address. So your nickname address is the logical address, real food address the physical address, and the delivery service operating system plus MMU which does the conversation. Key points to remember. Program uses logical virtual address. Computer memory uses physical address. OS plus MMU convert logical to physical. In some case like a compile time, both addresses can be same, but during execution they are usually different. Next, single process monitor. Monoprogramming. single processes. In a single user system, single processes monitor. Monoprogramming. In a single user system, everything is simple. Only one person of the program run at a time. Only one person process in a memory. The operating system does not need to convert addresses while the program is running. To protect the OS, it can be stored in ROM, which can be changed by user, or the OS can have their own spatial memory area that only the system can access, not normal program. This is called a supervisor mode. Or the OS can have its spatial memory area that only the system can access. Okay, OS has its own spatial memory area that only the system can access, not normal programs. This is called supervisor mode. Example: MS-DOS is example of such a system. It only run on task at a time and has a simple command interface, but this setup is limited. It's not powerful or fast compared to modern system. So what is contiguous allocation? Contiguous allocation method. Okay, contiguous allocation means that each program gets memory in one continuous block. Contiguous meaning that each program gets memory in one continuous block altogether, not scattered. Single partition system. What is it? The operating system is kept in a lower part of the memory. Single partition. The operating system is kept in the lower part of the memory. The rest of the memory is given to only one user. The only one program run at time. How is memory protected? Uses relocation register and limit register. Relocation register starting addresses to program in memory. Limit register size of memory allowed to program. This prevent program from entering the OS memory area. Real life example: imagine a kitchen. The chef's area. OS is locked. Only one person can cook at a time. Is a memory. Multiple partition system. Fixed site partition. What is it? Memory is divided into fixed size blocks. Each partition holds one program only. If the program is similar, then the extra space is wasted. Problem: internal fragmentation. Wasted space inside the partition that is not used. Internal fragmentation. Real life example: think of a movie theater. Each seat is the same size. All small person seat takes one full seat, wasting extra space. Variable size partition. What is it? Memory is not fixed in size. Each program gets a block that exactly fits its size. There is no internal waste of the beginning. External fragmentation: when programs add and they leave small holes in memory. These holes may be too small for new program. Real life example: think of a parking car. Each car gets just the space if needed. When some car leaves, small gaps are left between cars. New cars might not fit in those gaps. ऊपर फिर से देख लेते हैं. कंटीजियस एलोकेशन के अंदर कंटीजियस एलोकेशन सिंगल पार्टीशन सिस्टम, मल्टीपल पार्टीशन सिस्टम, वेरिएबल साइज पार्टीशन. ओके. What is contiguous allocation? Contiguous allocation means that each program gets memory in one contiguous block. Single partition system. In operating system, it is kept in the lower part of the memory. The rest of the memory is given only one user. The only one user run at a time. How memory predicted? User relocated register with limit relocation register, limit register. The safe area is OS is locked. Only one person can cook at a time. Multiple partition memory is divided into fixed size block. Each partition holds only one program. If a program is smaller than the partition, the extra space is wasted. In problem क्या आता है? Internal fragmentation, wasted space inside the partition that's not used. Think of movie theater. Each seat is same size. हाँ ठीक है. Variable size partition. Memory is not fixed in size. Each program gets a block that exactly fits in the size. There is no internal waste in the beginning. Program internal fragmentation. Each car gets just the space if needed. When someone cars leave, gap is left between the cars. New car might not fit in those gaps. Done. Paging. What is paging? Paging is a memory management technique that Paging is a memory management technique that helps fix the problem of external fragmentation found in variable size partition. How it works? Logical memory is split into fixed size block called pages. Logical memory is split into fixed size block called pages. Physical memory is split into same size block called frames. Each page of a program is loaded into one available frame in memory. They don't need to be side by side. Think of it like cutting a big book into equal size chunks and placing those pages into empty bookshelf slots. Page frame size are always power of 2. Like real life example, imagine a photo album with photo slots. You have a collection of photos. Imagine a photo album with photo slots. You have a collection of photo and each photo is placed in any available slots. You don't need to place all photos side by side, just need a slot. Paging is a memory management technique that helps fix the problem of external fragmentation found in variable size partition. How it works? Logical memory, physical memory. Page allocation strategies. When loading a process, we need to find the best place to fit its pages in the memory holes. There is a 3 popular allocation systems. Best fit policy. Choose the smallest hole where the process just fit. This reduce leftover memory. You have holes of this process will need this. I will go into 3. Best fit. Choose the smallest hole where the process just fit. First fit. Select the first available hole from the big enough. Worst fit policy. Choose the biggest hole so the remaining space is also big. Which is better? Best fit, less wasted space but slower. Less wasted space but slower. Fast, easy to implement, but many waste space. Some space. Worst fit, sometimes useful but often leads to large unused gap. What is paging address translation? When a process runs in generate logical addresses, these logical addresses must be translated into physical addresses by the hardware. When a process runs, it generates logical addresses used in program. These logical addresses must be translated into physical address used by RAM by the hardware. In paging, each logical address is split into page number and offset. This tells which page the data is on, tells how far into the page the data is. Imagine a 16-bit logical address. Okay. Page table. The page table maps logical page tables. Paging address translation direct mapping. Program generates logical addresses. Page number is locked up in page table. Combined frame. What is TLB? Translation look-side buffer. A small fast cache that stores recently used page table entries. How it works? First, if you check if the page number is TLB, translation look-side buffer. If found, hit directory frame number. If found, miss to the page table in RAM. Then add this new entry to TLD. Real life analogy. Without TLD, every time you need a phone number, you go look it up and in a big phone book. Paging protection and sharing. Memory is divided into pages, small blocks. Each page has a protection bit that says if it is a read only or read write. Different program can share the same page in memory to save spaces. Only non-changing code called rentrant or pure code can be shared easily. If a data or code can changes, it should be shared without control. Advantages of paging: can run big program even if RAM is small, avoids messy memory gaps, use all memory efficiently. Some memory inside pages may be wasted. Addresses translation must some overlap. Segmentation: instead of dividing memory into equal parts like paging segmentation, different sizes, people like to think of memory as many pieces of different size, not just a long list of equal blocks. Segmentation helps with this idea. Okay, instead of dividing memory into equal small part, segmentation divides memory into parts of different sizes. How segmentation works? Memory is divided into parts called segmentation. Memory is divided into parts are segmentation. Each segment can be different sizes. Segments don't have to be in order. Each segment has a number and a length. A memory address is given by two things: the segment number, the position inside the segment. These way programs are split into parts that make sense to the user. Even though address has two parts, the actual memory is one last of bits. Addresses translation in segmentation. A segmentation table helps convert a logical address into a physical address. The segment table stores base and limit. The starting physical address of the segment, the length of the segment. To find the physical addresses, take a segment number and offset from the logical addresses. Use the segment number to find the base and limit in the segment table. If the offset is less than the limit, to avoid error, add to offset the base to get the actual physical address. Protection and sharing in segmentation. Segmentation can be shared. Each segment has a protection bit. Programs can't access other segments unless shared. Sharing means pointing in the same memory. Some free memory is broken into small pieces. System fixes by combining free space. Real life example: imagine a library with books is a memory, and some books segments are common, like a directory used many people. Okay, like a dictionary used by many people. Okay, the dictionary book is read only. No one can write inside it, so everyone reads the same copy safely. Other books are personal notebook that only one person can use or write it. On the library shelf have some gaps between books. It's hard to fit a big new book. The librarian moves books closer to make room. Okay, तो summary इसका है. This unit teaches how memory is managed and how process keep safe from others. It discusses memory allocation method like swapping and overlays to use memory. Patching and segmentation are the two main ways, each with advantages and disadvantages. Patching divides into based on the physical part of the process. Segmentation divides memory based on the program logical part and how the user think about it. Fragmentation, internal external, causes wasted memory space. Technique like relocation and compaction help fix external fragmentation and improve system performance. Okay, done. ब्लॉक 2 में ये था, थोड़ा कॉम्प्लेक्स था, इसको अच्छे से और करना पड़ेगा और बेसिक वे में समझना पड़ेगा विद रियल लाइफ एग्जांपल. फाइन.